In this video, we will talk about option pricing relationships. There are different factors for different options, and for example, there's difference between the European and American options. And then time to expiration, what do you do if you have an American option, whether you want to exercise it before the expiration, right? How those uh, influence the option pricings. Also, how about different strike prices, right? Different strike prices in different options, even for the same underlying, same expiration date, what kind of relationships the different strike prices should imply for the option prices. And we will look at that. Uh, Also, influencing the early exercise option, early exercise decision is cash flow. The cash flow to the underlying or the cash flow for the delivered asset, right? In call option, you deliver cash for the underlying stock. So there can be interest paid to the cash that they're going to pay. And that actually influences the early exercise decision. So first, let's look at European versus American options. In what follows, we will use lowercase c and p for European options. American options, we use the capital C and capital P. Just make a difference, and this is the tradition in this literature. American options using capital characters or capital sized letters. Because obviously you can exercise American options before its expiration, but for European options, you can only exercise them on the expiration date. Right? There's more flexibilities in exercise timing, so obviously American options worth more than European options for both call and puts. And here we are talking about for the same underlying, for the same strike price, and the same expiration date. The same expiration date. So considering this kind of options, we know that an American option with the same strike price and the expiration date for the same underlying will cost more than its European option counterparty. Following the discussion between the difference of for the difference between European and American options, we can actually look at the so-called option pricing bonds. There are maximum and minimum for option prices. So let's look at call first. Obviously, call option give you a right to do something, so it cannot be negative, right? The call premium should be positive. It should have some value. But it should not exceed stock price, right? The call premium should be lower than the stock price. For example, if some stock worth $100 per share now, and the right to buy that stock at $100 per share sell at 120, you obviously won't pay 120 to get a right to buy something at $100. You just use your $100 to buy that share. Easy enough. And then we will apply our put call parity. Remember, put call parity is applied to European options. So we have the European call minus the European put should be equal to the present value of the forward price and the strike in the call and put. So we actually can say another thing here, which is the put price cannot be zero either, right? Cannot be have no value at all. Right? The put price give people some right, especially it actually provide the downside insurance. So put premium should be positive. Now, if this minus term on the left-hand side is the put premium is a positive number, what it means? It means the call option premium should be higher than the present value of the difference between the forward price and the strike price. Now we actually have this lower bound for European option. And then we know that American option has a higher value than the European option. So we line up this inequality saying what? The underlying stock is basically an upper bound for the American call option, which is also an upper bound for the European call option. And the European call option should be the maximum between 0 and the present value of the forward price minus the strike. So we have this upper bound, basically the underlying stock price, and on the lower side you have this maximum between 0 or the difference between forward price and the strike price taken to the present value. So that's for call option. We will look at a diagram to see what it looks like, and I will also give you further explanation. Okay, let's look at put option premium. What about put premium? What's its maximum and minimum, or the upper bound and lower bound? So put price cannot be more than the strike price. Okay? Because why? Because in the put option, you have the right to sell at the strike price if the underlying is below the strike price. Now, in other words, if the underlying is 0, the maximum amount you can receive is the strike price. Let's say again, strike price is 100. It means through this put option, the maximum amount you can receive is $100. But if somebody want to sell you the put option as 120, right? You pay the 120, only get a maximum possible money for 100. You're not going to do that. Keep your 120. Take the 100 out of that 120. You got your $100 now, right? Remember, the strike price is a future payment, so you have to wait until you can receive the strike price. And then the put price cannot be less than price implied by the put call parity with call price equal to 0. So we can flip the put call parity, saying put minus the call premium equal to the present value between the strike price and the forward price. So we just put a minus sign in front of the left-hand side and the right-hand side for the standard put call parity equation. And we get put minus call equals to the present value of the difference between strike price and the forward price. Now again, we argue that the call option should have positive value. It means the put option is higher than the present value of the difference between the strike price and the forward price. Now we can put things together, right? The strike price is actually the upper bound. The strike price is higher than the American put option, which is higher than the European put option. And then both these two options should be the higher value, right, of either 0 or the present value of the difference between the strike price and the forward price. So just the lower bound is different from the call, right? The call here is the present value between the forward minus the strike, and here for the puts, it's strike minus the forward price. Obviously, this is basically the payoff, right? The payoff structure. The put is strike minus the underlying, and the call, if in the money, is the underlying price minus the strike price. So that's the idea of upper bound and lower bound. Notice that so far we are considering from the starting point of European options. We have some basic relationships, but there's again the distinction between the European options and American options. So we need to further explore that to get more accurate statements for the upper bounds and lower bounds. Let's look at call again. Consider the options on the non-dividend paying stock S. Just make things easier. So we know that the American call should be higher than the European call, but both should be below the underlying current spot price for the underlying stock. That's easy. For the American call, right, it should be higher than either zero or the spot price minus the strike price, which is its intrinsic value, because call options have their time value, so their total value should be higher than its intrinsic value. That's easy to understand. But the intrinsic value, for the European put, right, is still this one. However, for European put, you cannot exercise it at this moment. You have to wait until the expiration to receive the strike. So what we have discussed here, right, is the present value of the strike that is working. So for the European call option, right, you have a lower bound that is the zero, the maximum between zero or spot price minus the present value of the strike. Now we have to compare, right? Is spot price minus strike itself a bigger number, or the strike price minus the discounted strike a bigger number? Well, because obviously the present value of the strike is a smaller number than the strike itself. We have discounted it, then the same spot price minus a smaller number, this present value of the strike, is actually the higher value, because American call has a higher value than European call, and the European call actually has a higher lower bound. Right? So we can actually conclude that American call option should be no less than the European call option, which has a lower bound of either zero or spot price minus the discounted strike. So that's actually our previous conclusion for the lower bound. Now, for the American call, right, if you exercise it instantaneously, you can actually receive the strike. But for European call, you have to wait. So the upper bound for European call is actually lower. You have to calculate the present value of the strike price. Okay, that's the maximum possible. The strike price on a future date is the maximum possible payoff to the put, European put. So you have to discount that strike price for the European put. In other words, the upper bound for American put is the strike, but the upper bound for European put is the discounted strike. What you have is the fact that the upper bound for American put is higher than the upper bound for European put. Now let's look at the downside. For the European put, right, it's either zero or a positive number if the discounted strike price minus the spot price is positive. Okay, that's the European put. For American put, It's the maximum between 0 or the strike minus the spot price. So for the strike minus spot price part, right, just for this portion, we can see the American put have a higher, assume both to be positive, right? The discounted strike minus spot and the strike itself minus spot. Both these two differences are positive. Let's assume that both are positive. Obviously, the present value of the strike is a smaller number, so the lower bound for the European put is lower than the lower bound for American put. So that's, again, we see some difference. We see some differences between American put and the European put for their upper bound and lower bound. And what if we have summarized for American costs and the European costs? It's basically saying these two have the same upper bounds and lower bounds, at least for a non-dividend paying stock. Now let's think about cash flow. And the cash flow going to the stock. Also, if you have the money ready to pay for the strike price, uh, it can generate interest. Another fact is that you may want to think about option on bonds, right? Coupon interest payment to the bonds is also cash flows to the underlying. And here let's let the present value of the cash flow be PV from time 0 to time capital T of the cash flow. Whatever the cash flow is, just summarize them into the present value. Now the lower bounds between the lower bounds for call options and put options changes their phase. You have to deduct the present value of the cash flow to the underlying from time 0 to time capital T from the spot price of the underlying. So for American call and European call, you have this, remember it's called a tailed amount, right? The tailed amount, or say the tailed price per share. Again, it's actually a present value of the future share price. Because this cash flow are not going to be received by the call holder, they are going to be received by the asset holder. You have to take them out. And this lower bound here becomes the max between 0 and the tailed per share price minus the present value of the strike. For European put, the lower bound is the max between 0 and the difference between the discounted strike price and the tailed per share price at time capital T. For American put, the lower bound becomes the maximum between 0 and the strike minus the tailed per share price. Right? So that's saying if you have cash flow to the underlying from time 0 to the time of expiration for the options, you have to deduct the present value of those cash flows from the underlying price when you're considering the lower bound. So let's go back to the non-dividend paying underlying stock for options. And this is what the picture looks like. For the upper bound, right, all the options should be less than the underlying spot price. And the lower bound either 0 or the difference between the spot price and discounted strike price. This portion is the positive lower bound, right? If this difference become negative, right, you go at the zero lower bound. So if we have the Black-Scholes pricing formula, what we have is this kind of line, right, for the option value. It's a kind of convex towards the strike price, this line, right? That's the option value. But without that, what we know at least is that this option value will be within this kind of light green region. Okay, the option value will be within this region. It will be below the underlying stock price and above either zero or this positive difference between underlying stock price and the present value of the strike price. So let's look at the upper bound and lower bound for costs from a picture. What I need to emphasize is this. It actually depends on where the underlying strike is. So this is the call value on the vertical axis, and the horizontal axis is actually for the underlying stock value at this moment. So let me get the marker. Get the highlighter. So that's the upper bound, and then you have this lower bound. This region is where the call option can be. Let's say what do we have? In the picture here, right, this kink is the discounted strike price. So let's say that value is, make it $79. The discounted strike price. It's the present value of the strike, $79. Then the upper bound and the lower bound for a particular price of the underlying is something like this. Looks like something like this. Let's say at this point, right, you have a straight line up. And here it's actually $85. That point would be $85. So that's the current underlying price. The lower bound value here is what? 85 minus 76, which is actually $6. Right? The upper bound is 85 itself. Right? If we look at our picture, right? Upper bound, lower bound is the stock price minus the discounted strike price. So what we have? What we can conclude is that this call option, be it either American option or European option. Anyway, we are talking about this call option, have this expiration date, which give the discounted value of the strike price. For this underlying currently trading at $85. It has this price range. It should be below $85 and above $6. Okay, that's the upper bound and lower bound for a particular call option. Now, how about for some value here, right? And let's say this value is, make it 50, make it 40, 45 maybe, 45. So if the underlying, right, is 45, and we can see that the lower bound itself is just 0 because obviously the call is way out of money. And the upper bound is still what, $45. Still $45. So for two different underlying price level, you actually have different upper bound and lower bound for the same call. Okay. What I want to emphasize is that it's not this whole region, right? The call option run around, right? Run around in this region. It's not like that. What happened? Let me see. What happened is this, right? Given different level of the underlying stock price, you have different upper bounds and lower bounds for the same call option. And the story is the same. The story is the same for the put option. Right? Given different underlying stock price, you actually have different upper bound and lower bound for the put option. Let me again just get a simple picture here. Let's use something that is simple. Well, to say it's simple, I just want to keep the same present value of the strike price, $79 as the previous example. Then we are considering a European option. Let's start with that, right? And let's say, well, the strike price itself, make it easy. Let's say that's $80. Let that be $80. $80. And then make it here 79, right? The present value. The strike price, let me see. Uh-oh. So actually, for the European put, right, what we have here is also 79. It's the present value for the upper bound, and the turning point is also for the upper bound. For the lower bound, the turning point is also the present value of the strike, both $79. Okay, that's um, for the European put. And let me just make the numbers a little bit more dramatic. Let's use a way higher number for the actual strike. Right? Make it this way. This is 45-degree line anyway. So 79 is the present value of the strike, but what we want to say here is this is let this one be the strike itself, let's say be 85. So 85 here. And the green region, right, the region outlined by the green line will be for American put. The blue line outlined region will be for the European put. Now, if again, let's say the underlying, right, let the underlying be, no, this way. Let the underlying be at here. Right? Say that's $40. $40. For the European put, right? The upper bound is at this point. Let me just have a here. This point is the upper bound, and 79 minus 40. At this point, 79 minus 40. This point is $39. Right? 39 at this point. Here's 79 itself. So for European put, right, the upper bound is $79 if the underlying stock price is $40, and the lower bound for that European put will be $39. Now, how about for the American put? For the American put, what we have is a upper bound, obviously $85. Lower bound will be the $85 minus 40, which is 45 at this point, right? It's this point, 45. 45 is the lower bound for the American put when the underlying price is 40, and 85 is its upper bound. Okay, it's always kind of on the vertical direction. You look at the upper bound and lower bound to see where the where those bounds are. Numerical example. So in this numerical example, we have the time to expiration is 42 days. Currently, the underlying stock price is $72. Risk-free rate is 4.5%. The dividend is 0. And we have two strike price for different options to consider. The lower strike price is $70. The other strike is $75. Obviously, we need their present value, right? So to calculate the present value, we need to use the 4.5% interest rate to discount the $70 and the $75. So it's a fraction of a year of 0.11507, and then we discount 70, we got 69.65. We discount using 4.5% for the about a tenth of a year. For this $75 strike, it's 74.62. Now, the first task is to find the pricing bounds for European call and European put. For European call, right? European call, the upper bound, or even for American call, it's the current stock price, $72, and the lower bound is what the maximum between 0 and the spot price 72 minus the present value of that $70 strike, which is the 69.65, which is 2.35, so $2.35. So for the European call with a 42-day expiration, it has an upper bound of $72 and the lower bound of $2.35. Now, how about the European put with a strike of $75? We remember that for the European put, the upper bound is the discounted strike price, which is we have calculated 74.62. The lower bound is the maximum between 0 and the difference between the discounted strike, right? Discounted strike minus the spot. Obviously, if the spot price is way higher than this discounted strike, that the lower bound will be 0. Something like, let's say $80, right? $80, this put option is out of the money, and the lower bound will just be 0. But here, this difference is positive, so the lower bound is $2.62. Okay, so for the European put, with a $75 strike and 42 days to expiration, you have an upper bound of $74.62 and a lower bound of $2.62. Now, the next task is to find the pricing bounds for American call with a strike of $70 and American put with a strike of $75. For the American call, still the upper bound is just the spot price, $72. And the lower bound is bounded by what the lower bound of that European call, because its value cannot fall below European call. It's not, right, $72 minus $70, the strike. It's not that. That's only $2. It should be higher than the lower bound of the European call option, which is $2.35, which is higher than $2. So again, for the American call with a $70 strike, you have this same range, right? $72 the upper bound, $2.35 is the lower bound. This is the same range for the European call. But for American put, everything go to the nominal value. This strike price, $75, okay, can be received instantaneously. So $75 will be the American put's upper bound, not the discounted value. And the $75 minus $72, if you exercise it now, you will get $3. So that is the lower bound. But obviously, there's still time value embedded in it. What if the underlying, right, keep falling from 72? You can get higher payoff. So the $3 is just the lower bound. Again, for a American put option with a $75 strike, the upper bound will be $75. The lower bound will be $3 when the underlying price is $72 and it has a 42 days to expiration and the interest rate is what, 4.5%. But for American put, it doesn't matter. It doesn't matter what the interest rate is. You know, the whole present value thing is gone. So now let's talk about the early exercise for American options, whether it's optimal to early exercise American options before the expiration. Some simple conclusions. Early exercise of a American call option is never optimal for a non-dividend paying stock. So if the underlying stock is not paying dividend, you hold your American option until expiration. You do not exercise it early. That's one simple conclusion, and you'd better memorize it because it's the easiest thing to remember and can be show up in your exercises and exams quite often. Why is that? Because it's a definite conclusion, right? If you have non-dividend paying underlying, you do not exercise your American call early. Concluded. But if it's for a dividend-paying stock, then early exercise can be optimal or rational for American call options. This is inconclusive. It all depends. We will discuss the different situations, but those situations are delicate, so it's harder to put them into some kind of question. But we will, see the economic rationale behind those scenarios. For American put options, okay, doesn't matter whether it's paying dividend or not, it can be optimal. It can be rational to exercise it early. You can exercise your American put options early, especially when the firm is close to bankruptcy. Right? The stock price is basically bottom out at 0, and you just scoop your strike price, right? Getting your strike price back and start to earn interest on the strike price. So what's the benefits from early exercise? The idea is basically to receive the target asset early, right? For the call option, you'll receive the underlying stock early, okay? And for put option, you'll receive the strike price early. If you do that, it benefits you a lot, you do it, right? Exercise the option early, then expiration date. So why do you want to receive the underlying stock early? If it pays a lot of dividend, right? To capture the dividend, you can pay your low strike price, and you see the dividend will be high, which is basically embedded in that stock. Start to capture those. That give you incentive to exercise your call option early. And then for the put, right? If you can make a lot of interest income on the strike price received, and the stock price is already as low as possible, especially when it's 0, right? The strike price is all that you can receive on exercising this option. And then after you receive the strike price, you can start to earn interest income. You want to exercise your American put early, then expiration date. Now, that's the cash flow paid to the target. If the cash flow paid to the target in the exchange, right, for options, it gives you incentive to exercise it early. However, if there's cash flow paid to the strike price, for the cash flow paid to what you have to pay in order to get the target asset, that will deter early exercise. So what do we mean? Think about the dividend paid on the underlying for the stock. Right? Think about it if you have a put. If this dividend on the underlying is paid out, right, then the underlying stock price will fall even lower. That gives you your intrinsic value instantaneously after the ex-dividend date. Intrinsic value of your put option will be higher just because the stock price has been lower because the dividend payout. So you actually don't want to early exercise your put if there's dividend currently paying to the underlying. Basically, the underlying price is still high, but after the dividend paid out from the underlying, you will be able to get a better payoff. Okay, so let me say it again. If the strike asset, right, is paying out dividend for the underlying stock, right, it's deter early exercise for put. How about for call? Remember, in call, if the call is in the money, you need to pay the cash, the strike price, right, to get the target asset. But then if you can earn very high interest on the strike asset on your cash, then probably you will think about not to paying out the cash so early. So that will deter early exercise on put as well. So it really depends on the cash flow paid to the strike price or paid out from the strike price for call and put. Now, let's look at our theory. So we start from talking about calls on a non-dividend paying stock. Again, we go back to our put call parity. We know that American call option has a higher value than a European call option, right? Everything else the same, every parameter the same, just one is American, one is European. So you can think about this relationship, and then we know the put call parity for the European call. What is the European call? You can have a synthetic European call that is a long underlying short the discount bond with a strike price par and a long put. That is basically the long put is an insurance, right? And if we want to think about the excess value, we got to say, all right, the call is in money. If I exercise the call option now, I will receive the spot price minus the strike. So I put spot minus strike here. And then I need to add it back so I have a zero impact on the right-hand side of this equation. So add it back. And then still you have this discounted value of the strike plus this put, which is downside insurance. So I have the exercise value. And what is this one? Right? This is basically, you can see the strike price minus its present value. So it's actually the time value of money. You can interpret it as the interest loss if you pay strike price now. If you pay strike price now, you pay the whole X. But if you pay until the expiration, you actually paying out the discounted value. Right? You only pay it at the expiration. So the present value now for that future payment of X is its discounted value. That's the interest loss if you pay the strike price early. It's the time value of money for the strike price. And then put is basically that insurance part. Right? You have an insurance, you have time value money saving on the strike price, not to pay it too early, right? Embedded in this call together with its excess value. So what we are saying here, the call at least worth the excess value plus the time value of money of the strike price plus a insurance on the downside. Okay? If that is the situation, your call certainly have a higher value than the excess value, which is the spot price minus the strike, because you have time value of money on the strike, you have an insurance inside the call. What's the conclusion? It's never optimal, it's never rational to early exercise your American call option on a non-dividend paying stock. Again, this is the conclusion, one clear conclusion. If the underlying stock is not paying dividend, you never early exercise your American call. Right? Non-dividend paying underlying American call. No early exercise. Memorize that. All right, now let's see what's the effect of dividend paid to the stock. We know we have to deduct the present value of that cash flow from the spot price. And here we just invoke the put call parity on American options. It's okay. We haven't discussed it before, but we can certainly understand it. For American options, the put call parity should hold as well. All right. We do the same trick, right? We put the exercise value here. And we have this time value of money for X. What we need to take out is the present value of the dividend plus this downside insurance from the American put. So if it's optimal, right, to early exercise the American call, right? If this whole thing, right, is less than this exercise value, this long sum is less than that, it's basically saying what? The tail here, right, beyond the exercise value, the time value of money for the strike price, the present value of the dividend, and the put premium, all these put together, it's less than zero. It hurt the whole value of American call option. Then, that's the condition you should exercise early. So what we can say here? What we can say here? If we rearrange this inequality, saying the time value of money on the strike price minus the present value of the dividend plus the put premium is less than zero, rearrange it a little bit, we can say the early exercise condition for a dividend paying stock call option, American call option, is say the dividend, the present value of the dividend is higher than the sum of the time value of money on the strike price and the put premium. So when I'm not exercising the American call early, I have the time value of money on the strike price belong to me, the put premium belong to me, but I give up the dividend paid to the underlying between now and the expiration date. So if that dividend is very high and time value of money on the strike is not high, put option doesn't worth that much, then I should early exercise, right? Exercise my American call option early. So that's the kind of theoretical condition. Realistically, we can think about the following scenario. If your underlying now is selling at $100, strike price $90, exercise it now, you get $10. But the dividend, right, gonna be paid to the underlying is $99.99. Then after the dividend has been paid to the underlying, what do you get? 1 cent for the underlying stock. In other words, the underlying stock price will plunge towards zero after the ex-dividend date. Then what do? You exercise it early, right? At least at the last moment before the ex-dividend date, right? Get your $10 in the money amount, and basically the underlying now worth $100. You paid $90, but then you got the $99.99 paid to the underlying. Right? Get that $9.99 and whatever left in the stock. So that's a scenario, right? You have a tremendous amount of dividend paid to the underlying. It can be optimal to early exercise your American call option. Now, when early exercise is not optimal for American call option for a dividend paying underlying stock, now we can look at this one. Let's say this is the time value of money, and this is the present value of the dividend. Right? So if the time value of money, right, you pay the strike price early, you have to give up a lot of potential interest income, and you don't get much dividend, you do not exercise the American call option on this stock early. So that's for American call option, right? The decision to early exercise American call option on a dividend paying stock. Let's think about American puts, whether you should early exercise American puts. And we put the dividend here. It's kind of same starting point as before, right? We have this synthetic American put with one long American call and a short position on the underlying, we have to add the dividend back, present value of the dividend back, add the present value of the strike price back. So kind of long, right? This is kind of long discounted bond for the dividend and for the strike. Anyway, that's um, from the put call parity on American options. And again, what we do, we put the excess value back. If we exercise the American put option early, we get the strike price minus the underlying. Because I have added the strike price, I need to deduct it. So this is basically the negative of the time value of money for the strike price. Then again, plus the present value of the dividend, plus the value of the American call option. Still, if the portion in this right-hand side formula, right, after the excess value is negative, then you should exercise it now, right? So what it means is basically it makes the American put option has a smaller value than its excess value. That's why you should exercise it, right? No longer worth that much. You just get your payoff and close it. What it says is basically the negative of the time value of money for the strike plus the present value of the dividend plus the call option is less than 0. And again, we rearrange it a little bit. It's basically saying the time value of money on the strike, right? What you have to give up, what you're going to receive, right? For that, for early receiving the strike, right? It's actually what you have to give up for receive the strike early. Let me see. It's what you can get from receiving the strike early, right? You either receive it today or receive at the expiration. But at the expiration, you receive this full X. For today, you have to discount it. So this time value of the strike is what you gain actual when you receive the strike early, right? You exercise your American put today, you get X, the strike price. And then what do you have to give up? You have to give up your call option, American call embedded in the American put. You have to give up the potential income to the underlying. You are going to deliver the underlying stock, which is paying a dividend. Right? You give that up. So if the benefit, if the gain from received strike price early outweigh, right, the dividend you can receive and the call option value, you should exercise your American put now, not to wait until expiration. So what we are saying, if the value of the call option is very low, right, call is way out of money, basically the stock price is very close to 0, then early exercise your American put option can be optimal. And or the dividend is tiny, close to 0, right? What are you going to receive for the underlying? 0. Call option value 0. These two numbers very low. Then exercise your American put options early. Now, when the dividend is 0, what's gonna happen, right? The stock is very low. If it still pay a high dividend, people will pay good price on the stock. But if it no longer pays dividend, stock price is very low. It's basically a situation that is close to bankruptcy. So you would like to exercise your American put options early, right? you can no longer make higher payoff from the underlying. The stock price is basically zero, but you can earn extra interest, right? Earn extra interest from getting your strike price early. So that's the situation when you should exercise your American puts early. The underlying stock is basically zero. However, if on the other hand, right, this call option value is higher than the difference between, right, what you can receive from getting this strike price and what you have to give up for delivering the underlying, that present value of the dividend, then exercise early is not optimal. In other words, interest rate not very high, right? You cannot gain much from the strike price, and let's say the dividend is quite significant, right? The present value is not close to zero. So when interest rate is close to zero, you don't get much from the time value of money, but the dividend on the underlying is quite significant, right? By keeping the underlying longer in your hand, you can receive money. In other words, the stock price is pretty high, right? And that make the call option quite valuable. If the stock price is high, obviously the call option is valuable. And in that situation, you do not exercise your American puts early. What it's saying is this, right? It's a good stock. It's paying high dividends. The price is far from zero. Then you do not early exercise your American put option. But the situation where you early exercise your American put option is when the underlying is very close to zero to do the early exercise. For American call, right, is basically this. There is a impending significant dividend payout. Then you exercise it early. These are for dividend paying stocks. Okay. The next topic is time to expiration. Let's say T2 is a further time than T1 from today. So if an option have an expiration of T2, it has a longer life. Now, what do we know for American options? If the American options have longer life, it will have a higher value. Because why? Because you can always exercise your longer maturity American option on the earlier date, on T1, right? T2, let's say T2 is 1 year later, T1 is 6 months later. You can always exercise your American option on 6 months later, right? On that 6 months later expiration date. Then naturally, right, for American options, if it has a longer life, it has higher value. Let's think about for European options. We still need to separate the situation whether there's a dividend paid to the underlying stock. Now, for non-dividend paying stock as the underlying, we know that you never early exercise American call options. Right? We just get that conclusion. If we never early exercise American call options, they have the same value as the European options. And then we just need to compare, right? Which European options has higher value? Turns out, still the one with longer maturity, the one with a further away expiration date has higher value. Why is that? Let's consider on date T1, the closer expiration date, right? So what we are saying here is that this option on date T1 has an expiration date on T2, right? It has a lower bound of the maximum between 0 and the the spot price at T1 of the underlying minus the present value of strike price. Right? You discount that from T2 to T1. It's a European option. You're only going to receive the strike price on T2, the further away expiration date. And the current time is T1, so you discount it from T2 to T1 for that strike price. Because you discounted the strike price, right? This value is actually a higher value than the spot price at T1 minus strike price itself. But that is exactly the lower bound here for the European call with T1 expiration date. The European call expiring today, its payoff is simply either 0 or the current spot price minus the strike price. But T2, there's still some life, there's still a chance in the longer maturity European call there, right? It still have a chance to become in the money or further deep, right? Or getting deeper in the money. So there's time value there. And that makes the European call with a longer maturity of a non-dividend paying stock have a higher value. Same for American calls. Right? So if the American call on a non-dividend paying stock, it has longer maturity, a further away expiration date, it has higher value. Now, the rest will be up to discussion. What if there's dividend paid to the underlying? Now, for European calls, right? If in between T1 and T2, the time I marked as 1.x, right? Somewhere between 1 and 2. If between T1 and T2, there's a large dividend paid to the underlying, the result is a significant deduction in the underlying price, which make the spot price at the second expiration date, right, the further expiration date, much lower than the closer expiration date. Then it's possible that the call option price, European call option price with the longer maturity is lower than the European call option price with the shorter maturity. Okay, so when there's a significant dividend paid between the two dates, right? It's possible we'll drive down the call option price with the further away expiration date. How about for European puts? Well, again, this is where option with a longer life may not have higher value. There are two situations which make this possible. One is, well, the expiration date on this European option is super far away. It's 100 years later, right? Which basically make the present value of that strike price very, very low. And remember, the strike price, the present value of the strike price is the put option's upper bound. If the time for the put option to expire is very far into the future, its upper bound is basically getting closer and closer to 0, make this option have a very long life, have very low value. That's one condition, right? One kind of scenario. You have a very far expiration date for this put option, drive down its value. You rather have a put option that can give you X, have a chance to give you X closer, on a closer date. Another scenario is this. The stock becomes 0, right? The company went bankruptcy before T1, right? At both T1 and T2, it becomes 0. And then you can, with the longer maturity date, expiration date, you have to receive that strike price at T2, a further away, uh, a further away uh, expiration date. Right? Then compared to T1, you can receive the strike price with the put option that has a expiration date of T1. Right? On T1, you already received the strike price. But for the option with T2, you have to wait until T2 to receive strike price. And then you have to discount that to T1. Okay? So if the stock price it becomes 0 on date T1 and will be 0 on date T2 as well, what's going to happen for the European puts? The European put with a closer expiration date have a value of X, but the European put option with a further away expiration date have a value of present value of X on date T1. So that makes the European put option with further maturity date, expiration date, has lower value. Okay, so basically for European calls and European puts, it's not necessary. It's not necessary for the longer maturity, further expiration date European options have a higher value. But it's always true for American options. For American options, if you have a longer expiration date, a further away expiration date, it's always good. For European calls, right? If the underlying is not paying dividend, it's good to have a further expiration date. But if there's dividend paying to the underlying, the case may not hold, right? It can be the case if there's a large impending dividend payment to the underlying, the European call with a far away expiration date have a lower value, has a lower value. And then for European puts, it's just the far away expiration date may not add to the value for different situations. Okay.